Welcome back to another episode of Freeform AI. My name is Michael Burke, and I am not joined by my co-host today. He is taking an extended vacation, as he deserves. Today, we're speaking with Victor. Victor got his PhD in Information Systems from City University of Hong Kong, and after that, he was technical instructor at MIT, a researcher at IBM, principal at Cloudera, and most recently, a principal research engineer at Microsoft. So, really fascinating background, lots of stuff to chat about. But Victor, I wanted to kick it off with the fact that you've lived all around the world: Greece, Hong Kong, New York, California. Have you tried to move as much as you do, or has your career simply brought you to these places?
Yeah. So first of all, hi everyone. Thank you, Michael, for inviting me. It's a pleasure to always connect with other people in the space. So this specific question, I kind of get it a lot. And typically some people will say things like, when I was 6 years old, I had a vision that I was going to live all over the world and I was going to do X, Y, Z. And I think all of that is baloney. It's not true. That's typically not how it happens. Essentially all of these like moves living on 4 different continents, it's mostly just putting one foot in front of the other and figuring out what's the next interesting thing to do. And so for example, in terms of my background, I did do a master's at Carnegie Mellon, so spent some time there. And while I was there doing a master's in information networking, which is a mix of software engineering, distributed systems, and some focus on security, there was this opportunity to sort of move to Greece because the Carnegie Mellon Information Networking Institute had like a partnership with a research institute in Greece, in Europe. I'm like, yeah, it looks like I'm gonna learn a ton, and there was like funding for that collaboration, and so that's how I made that move. After my degree at Carnegie Mellon, I moved back to West Africa, where I'm originally from, and at the time, most merchants had just started to come online, and there was this 2 problems. So the first problem was that the local banking infrastructure had no way to accept to sort of interface with online merchants. So there were the payment portals and all of the local banking infrastructure were not connected to the internet properly. And so I spent some time building out SDKs for that for local payments. And then the second thing I did was I looked at the app stores. At the time, they were becoming popular. Smartphones with like real good capabilities were becoming a thing, and there just were no apps for that region. And so I started to make games for the African demographic, and I spent some time building out some of the payment infrastructure for local merchants. And then once I did that for a little while, I'm like, okay, um, I have this degree in computer science. I've done a ton of software engineering. I want to spend a bit more time looking at the business and the human side of things. And naturally, I wanted to do a PhD. And at the time, the information systems department at City University of Hong Kong was, I think, the largest in the world at the time. And the president for the Association for Information Systems was a professor there. And so I reached out. I'm like, hey, I want to study all this interesting stuff. What does that look like? And sort of once all of that worked out, I moved to Hong Kong. I lived there for about 4.5 years and did a PhD. Got to see that part of the world. And a lot of people ask me, hey, you have a degree from CMU, Carnegie Mellon. Why did you make that switch? Just at the time, I had lived in all these places. I'd never been to Asia, seen that part of the world. And the research direction I was interested in just made sense for that particular university. I'm like, yeah, I'm going to do it. And once I was done with the PhD, and I know this is getting long winded, but once I was done with the PhD, at some point, I did an internship with IBM Research in Yorktown Heights, New York. And after that, sort of kicked off the rest of my career story. So yeah, that's sort of what happened with all those different moves.
That's super interesting. A lot of our listeners are practitioners in the space, and it's fascinating that you sort of take it one step at a time. So you didn't plan more than one step, would you say, or was it 2 steps? How would you think about it?
And so and so the version of me back then, so this was like 10, 15 years ago, mind you. The version of me back then is really different from the version of me right now. And so that guy, he pretty much was doing like one or two steps at a time.
Mm,
Excuse me. And it was more like, you know, okay, I have I learned all this stuff with my master's degree. How do I apply it? And so I went to fix some stuff in the African ecosystem, and and then I did some teaching. I loved it. I figured, hey, now I want to do some research, learn a bit more in some specific areas, and then I did that. Um, but once I transitioned to the workforce, once I started at IBM, and as I've grown in my career from a research staff member to a principal research software engineer, I think being a bit more deliberate about the career sort of becomes even more important. And so you constantly should be thinking of like, okay, everything I do right now is a bit of an audition for the next job, and also with line of sight to what I want to do in the next 5 years. And so when you're earlier in your career, I think it makes sense to optimize for knowledge, learning, and the very thing that sort of builds like just knowledge and skill in the near term. But as you get like as you get older, at least this is my experience. As you get older, you need to be a bit more strategic as to how what you're doing today would essentially be an audition for the job you want to do like in the next year, the next 2 years, and how all this factors into where you want to be in the next 5 years. Um, sort of my thoughts on that right now.
are you willing to share what the next 5 years look like for Victor?
Oh yeah, sure. Um, so today I am a principal research software engineer, and we might get into what that means at some point in this conversation. And over the last 2, 3 years, my work has transitioned from, let's say, about 70% just writing code and sort of trying to look around trying to figure out what's around the corner for, let's say, a specific area. In this case, it's AI agents or how we build software with AI, and what kind of tools we would need to sort of navigate this sort of transition. Um, and so that has been my goal. What's right around the corner? Um, how can we build out? How can we sort of build frameworks or tools that help us sort of take advantage of all of the new capabilities we're seeing with AI? And how can we build developer tools that sort of enable that? And I think for the next 5 years, I think that will still be like the critical thing. I think the way we build software is going to change, and I want to continue to focus on that. But the one thing that might change is how much code I actually write for that. And so, over the last few years, it's sort of transitioned from about 70% code to more of about 40% actually building stuff, usually the first version of something, and then building a team around that, and essentially ensuring that we can execute and scale on that thing to sort of build like just much bigger value. Yep.
Got it. Yeah, that seems like the more and more of a principal role. You go explore the world, see what's important, try to align that with whatever values your company has, and then execute with a team. Is that
Yep.
right?
Yep. That is correct. And so at this level, um, it's important to first be be ambitious, figure out what the vision is, communicate that clearly. A lot of writing, a lot of presentations, usually backed by a lot of experiments. And then often it might include building the 0 to 1 version of that thing, and then socializing it, sharing it, and then figuring out the skill and the value story. Yep.
Yeah. I'm curious, what are the things that you, as a principal, try to optimize for? Like, if we take a step back, there's an entire world of AI stuff, right? You could
Mhm.
be building AI assistants, you could be building software tooling that helps people build AI assistants, you could be working on the foundational models themselves. There's so much in this space, and everybody's so excited. So, you got to move fast in theory, you got to
Yep.
go capture value.
Yep.
So, how are you distilling all this complexity and finding first principles or axes of your decision that would guide and lead to the correct result?
Yeah. Um, so I think this will be personal for everybody. there's a temptation to try to do everything. You can't. You definitely can't. I like the way you structure things into multiple areas. So the folks building the foundation models. I think those guys are probably in today's world. In my opinion, I think those guys probably are we'll call them the foot soldiers or the base sort of foundation of everything. And they're probably the most important in some way. Um, but then that type of work is extremely specialized. And you probably know it takes a ton of money, a ton of resources to train a model that is useful or valuable in any meaningful way. And so, um, if you haven't been doing that over the last 2 years, it can be a bit challenging to really sort of have that as a focus. I mean, you can still train small models, you can figure out fine tuning and all that, but that's one bucket of work. Another bucket of work is tooling. Um, and so, which is kind of what I have spent the last 2 years on. And the premise is as follows, right? The models are getting better. GPT class models, the cloud class models. Um, and essentially, a lot of the opportunity here is that we can rewrite existing software to be, let's say, perform better, um, depending on what your business case or uh, your user metrics are. We can rewrite existing software to be more performant there. So this might mean like just higher like task completion metrics, or even things like maybe just better developer user experience or that sort of thing. So that's one sort of area. And in general, while everybody's excited about this, not everybody has the skill to actually get it done. And so one way you can create value is like you can figure out like, okay, what are the key parts of these types of tasks or these types of app rewrites or modernization, and you build the right abstractions into a framework. And then suddenly there's all these teams who don't know much about AI agents, and then they can sort of capture some of that value. So that's the second thing. I think that's a lot of the value prop with AI frameworks or tools. Everybody, there's an opportunity for everybody to sort of take advantage of like AI agents and AI applications, but not everybody has the skill to do that. And so we build abstractions that make it easy to do that. And
That
then the
makes
third
sense.
piece is AI verticals. And so you take an area like finance, or say the kind of thing that all the suite agents are doing, Cursor, Cloud Code, Codex, and then you build specific AI agents for each of those. And so those are like the three high level areas. And it's useful for anyone listening to figure out which of these three do I want to get into. It's probably a stretch to get into more than one of them. But for me right now, it's currently in the middle tier. How do we create tools? And so it's things like Autogen and Microsoft Agent Framework, that sort of thing.
And do you like that space? Is that why you chose it? Do you think that's where the money is? Like, what's the appeal?
Okay, so I could use this opportunity to sort of talk about how I got into like agent tooling and some of that history on my end, or yeah, and maybe at some point I'll sort of talk about my background before that. And so I joined Microsoft Research about 4.5 years ago. Um, and at the time, I joined a team called the Human AI Experiences Group. And essentially, we cared about like any type of scenario where you have a human collaborating with an AI model or an AI agent to accomplish a task. And one of the first things we sort of worked on was GitHub Copilot. And at the time, GPTs were not like a thing. I mean, they were a thing, but like um, the model at the time was the Da Vinci 2 model. Do you recall those?
Yeah, oh yeah. Pre 3.5, right?
Exactly. So this was, I think, um, early 2022, and GitHub Copilot I think it was in public preview, and we had a ton of telemetry data. And the mandate that my team had was to sort of look at this like millions of telemetry that came back from GitHub Copilot, um, figure out ways to improve the developer experience and improve the product overall as we sort of march towards GA. One of the things we did was that we spent a lot of time looking at metrics. So how we evaluate candidate models in um, offline versus the kind of metrics, the kind of online metrics we were seeing. And so one of the things we saw was that at the time, the way we evaluated candidate models was this metric called passed K. And so what that means is that we have a set of functions. We strip out the body of the function. We give that to the model. The model completes the entire thing. And we have unit tests, and we sort of run this test against uh, the generated code against the test, and we get like an O1 score. So it's an absolute score. You pass or you fail. One of the things we saw in telemetry was that most people were accepting 1 or 2 line completions. And so in our offline test, this model, we're evaluating the model against the ability to write, let's say, 30, 40 line full complete functions. But what people were making decisions on were like 1 or 2 line completions. They were making like accept rejection tests, decisions there. And our test just had no way to sort of quantify how well the model did on this lower level granularity. And so we designed a bunch of new metrics that made it into the production pipeline that helped us rank, say, a couple dozen candidate models that we had, and then decide which ones we A/B test and which ones we promote to production. So I did that for a while. And then after that, I built something called LiDAR. So LiDAR is perhaps, let's say, the first interface, full-on interface that lets users drag in their data, and it shows them a set of data visualizations that make sense for the data. And so the core premise there is that a lot of our customers at Microsoft, and I guess everywhere, they do need visualizations, because visualization sort of, you look at a visualization, you can extract insights really fast. It reduces the cognitive burden associated with making sense of data, as opposed to scanning like hundreds of thousands of rows. So very, very important, but most people just didn't have the skill to create them. And so to create a visualization, it turns out that you need to understand the data. You then need to figure out what type of visualization you're going to use: a pie chart, a bar chart, a radar chart, all that stuff. Um, and once you did it, you either needed to use like a tool like Excel or Fabric or Tableau to sort of implement that thing, or you write code. And so, what if we don't require any of those capabilities from the user, but instead they just drag in their data, um, and we give them a set of like visualizations that make sense of the data. And if none of that worked, then they could do things like, hey, change this to that, all in natural language. And this was, I built this as part of an internal hackathon at Microsoft. This was sometime in July, August 2022. So this,
That is early. Wow.
so
No
there's this,
kidding.
yeah. So I'm glad that you know your dates, because the key part is that ChatGPT came out in December 2022, and Code Interpreter came out like 6 months later. And what this tool did was that you dragged in your CSV file, and it was a 4 stage process. The first is something called data summarization. So we take the data, we extract all of the atomic types, all of that, and we get the model to annotate each of these fields. Like, let's say, I don't know, it's string, but it's actually the names of countries. And so you have the semantic annotation, all of that. And the key part is that the model makes a lot less mistakes if there's some type of semantic description of what the data is. Then you take that first representation, then you give it to something called the goal or hypothesis generator that just says, here's this data, here's its properties. Give me n potential questions and the associated visualizations with rationale that make sense for this. And once you have each of those goals or hypotheses, you give it to the model again. Hey, generate a bunch of code that satisfies this user goal. And once you have that, you execute the code, you do post processing. If there are errors, that sort of thing. Excuse me. If there are errors, that sort of thing, you sort of recover, retry until you have a set of visualizations that you can then show the user. And so if you think of this today, you would call that thing an agent, because there's a tool. It's using a code interpreter. It's executing code. It's reviewing the results. It's doing error correction, correcting the code, that sort of thing. And so that was like one of the first like agentic things I did. And then once I finished with that, there were a bunch of folks at Microsoft Research who had started to think of the idea of conversational programming. And essentially their thesis was, rather than a developer like me having to write this four-stage pipeline, how about we define a discrete set of agents and we could give them arbitrary tasks, not just data visualization, and they'll come up with that workflow via conversation. And the first implementation of that thing was Autogen, became Autogen. And so it was my ex-colleague Chiwang started that project. And at some point he's like, hey Victor, you're doing all this stuff. How about we? I'm like, yeah, exciting. Like rather than me having to write this pipeline, how about we work towards a system where agents sort of discover the right solution, the right pipeline for a problem via conversation. And hopefully this scales to like multiple problem domains. And over the last 2 years, that's pretty much what we've been trying to accomplish with agents and tools and frameworks.
Wow. Okay. That is super helpful background and super fascinating. So Autogen, it seems like a lot of this was just born out of a need and an interest, but Autogen is has a very plugin focused model. So I'm curious, like, why are you guys approaching agentic development in this way? How do you sort of see yourself in the space between LangChain and Llama Index and all these other theoretical competitors? Like, what's the market niche that Autogen is trying to nail?
Yeah, so I think it's hard to tell which came first, Autogen or LangChain. Everybody's evolving all the time. I think even on Autogen, we've had three big iterations. And so every 6 months or 1 year or so, we learn a lot and we figure out, hey, we need to sort of reinvent ourselves. And with Autogen, we did that. I think about a year ago, we came out with Autogen 0.4, which was a complete rewrite of Autogen. And I could get into the details of that, but it was around making it a bit more production ready, a bit more scalable, and having essentially that rewrite sort of made the entire framework async first. So I think every framework should be async first. We didn't have that, which is really bad. The second thing was that it was modeled around the actor framework. So the actor framework sort of says that to build, it turns out that you can build like really complicated scalable systems if you model everything through message passing. So you have an actor, it doesn't really need to know about other actors within a network. And essentially, this actor gets triggered when it receives messages, and it can affect the outer world by emitting messages. So everybody just independent as long as they can accept messages, process it, and emit messages. So just fundamentally message passing. And really, really great idea. Provided the foundation for scalability, just a really good way to think about like distributed systems. And we sort of built that as the core API layer. The one challenge there is that, and it's one of the things I'm really proud of in terms of like my interaction with the project. While this is great, to write a simple agent is about 250 lines of code, and we were gonna go out with it, and I'm like, no, 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 no. The technical stuff is great, the idea is wonderful, but the developer experience is just not there. And so one of the things I sort of pushed for was a high level API on that core API. That's something we called agent chat. And essentially it's what everybody does today. So there's an agent class and you don't need to know anything about the runtime that's underneath. You don't need to know anything about message passing, about registering an agent with this runtime that does like message delivery. You don't need to know anything about that. You just create your high level agent class and you pass in the model client and you pass in a list of tools. And if there are memory modules, you pass that in. And in 5 lines of code, you have the agent defined pretty much. And then to run it, you just do agent.run. And when you do that, it does all the stuff underneath. So it sets up the runtime, it registers the agent with the runtime, all the message passing infrastructure, all the prints, all that stuff done. And so that was like one of the, I think, things that we're really proud of with like with Autogen, especially the rewrite. And I think Llama Index at the time was already thinking in that direction. So I wouldn't say that like, hey, we were the only ones thinking in that direction. And I think LangGraph, the new LangGraph 1.0 sort of follows some of those directions. And so that was one iteration of like Autogen. The next iteration, the more recent one, which you might not be familiar with, Michael, did you know that Semantic Kernel and Autogen, both teams have come together and we've released something new called Microsoft Agent Framework? Did you know that?
I did actually, yes. I didn't know
Okay.
the two teams joined though.
Yeah. Yeah. Okay. Okay, yeah, that's it's great that I'm here and I get to talk about it because not a lot of people might know that. But as usual, at a large company, there's always the possibility that there are really smart people working on similar problems and making a lot of really good progress. And essentially, that's the story of Autogen and Semantic Kernel. And so Autogen started out at Microsoft Research and sort of grew. And in the community, we got a lot of traction. So I think as at now, it's at over 50,000 stars on GitHub. And just a lot of people, a lot of startups have this thing in production. Um, and at the same time, Semantic Kernel made a lot of progress. Started out with C Sharp, not Python, and then over time learned that hey, you get to have both. And out of the door, they were more like enterprise and production focused, and so they made a lot of good decisions in that space. And so, sometime last year, I think about like April or so, it did become apparent that for us to sort of minimize confusion, because there were always these things about like, do I use semantic kernel? Do I use Autogen? And this was just not a good way for users or customers to spend the time. And you're like, oh, how about we sort of take the best of both frameworks and we create something that works really, really well across the board? And so both teams sort of came together. And it's one of the things that I'm really proud of last year, because it can get hard to merge two different teams or projects together. And we did that and we released Microsoft Agent Framework. And think of it as bringing the developer experience, the strong, clean developer experience that Autogen had, and pairing it with the production considerations that Semantic Kernel had. And it's also multilingual. So there's a full C Sharp implementation and a Python implementation, and we are doing our best to keep both at feature parity. And I guess the last thing I'll say, because you're probably thinking, like, what do I think might be the nicest part about like Microsoft Agent Framework? Why is it different from either of the two? So I think Microsoft Agent Framework is production ready out of the box, and so one example of that is that um, as opposed to just a focus on agents that run locally. Um, a lot of the abstractions can be backed by services. So, for example, like the Microsoft Azure Agent Service, a lot of agents abstractions are backed by that. If you wanted this thing running the responses API on the back, you could do that quite easily. You could also write your own agents with a framework, with any framework, and deploy very, very easily on the Microsoft Azure agent service. We call those hosted agents or container-based agents. You write it, we'll host it, we'll scale it for you. And then all the useful things around like security, I think that's much better supported here. And so in the new framework, there's the concept of middleware, which LangGraph also has. And essentially, you can think of them as hooks to sort of modify the behavior of your agent. And so it's sort of common that like you might need to write things like observability hooks, responsible AI hooks, things that run before and after model calls, things that run before and after tool calls, that sort of thing. Things that run before and after the whole agent executes. And so there's full support for stuff like that. And then finally, we also ship like a sample web application experience, something called Dev UI that when I built it, I'm really excited about it. It's a it's a essentially a web experience that lets you sort of test, debug, extend your agent. And so it starts with code, so you can write your agent however you want in Python or C Sharp, and then you could wrap it essentially. Serve it using the Dev UI tool. It opens up a web interface, and then you can sort of interact with this thing, look at observability logs, transfer of of messages, progress of the agents, and you can modify the code to hot reload, sort of see how the agent behavior changes. And so these are like, I think, useful things that we brought over to agent framework just to make the development and deployment experience a bit much stronger than whatever Autogen or Semantic kernel could provide.
Cool. A lot in there. I had a bunch of questions, but thank you for walking through that. That's super interesting, and I feel like that's how I've seen software evolve at Databricks as well. You start off with a use case, you build it, you get feedback, you iterate, you build feedback, and you just keep looping and looping until you're hopefully meeting a need, or you're maybe the top player or top set of players in the space and you can slow down a bit, but ideally you keep that iteration velocity as fast as possible and you
Yep.
get the purest signal for feedback.
Yep.
One
Yep.
thing that I thought was fascinating, and I agree that async first is really important, but actor first is a very strong decision in this space because if you think about the continuum, you could have one really large LLM that does everything, or at least from my interpretation of what you were saying, you can have sort of a swarm of smaller agents that do a bunch of small tasks that are lighter, cheaper, faster.
Mm.
Are you guys subscribing to one side or the other? And obviously, Microsoft Agent Framework, it's going to have support for everything, but did you start subscribing to the swarm paradigm over the large LLM paradigm?
Yeah. Um, so Autogen started out as a multi-agent framework right out of the box. We we um, we just made the bet very early that like having multiple agents iterate on a problem is where you get the most value. Now, um, that that might not hold true for all use cases, but there's this quote, the society of mind kind of philosophy from the early days of AI that talks about how, very close to your suggestion that like you can accomplish complex behavior by delegating things to individual um, um, components. And I think some of this boils down to the question as to, do you need multiple agents or you need just a single agent? Is it more helpful if you just dump all of the instructions into one very, very large agent? It has like 10 pages of instructions and it just calls itself in the loop. And hopefully, every time it needs to do a specific thing, it can find the quadrant of instructions that is useful for that and apply it. So, in many ways, the question sort of devolves to that. Or do you sort of parse expertise across multiple agents and figure out a way to delegate to each where it makes sense? And I wrote this book called like Designing Multi-Agent Systems, mostly to organize my thinking on that specific question and how to build that sort of thing. And in chapter one, there's something I call the complex task perspective. And the argument there is that there are, I think, 4 or 5 things that if your agent actually satisfies, if your task satisfies like those requirements, then it's likely you need multiple agents. And so the first is planning. And so do you have a task that benefits from being structured into a set of discrete steps where success in each of the steps leads to success of the overall plan, overall task? If yes, okay, you're getting closer, you probably might need multiple agents. The second has to do with diverse expertise. And so is your task structured such that each of the steps might need diverse, like completely different expertise. And so an example is software engineering, potentially, uh, where you might have something, okay, build me an Android app. You need to do some requirements gathering, so interface with other agents or a human. Um, you might need to do UI design, figure out the markups, that sort of thing. And then based on those, you might need to write the code. And then you might need to build the backend API. Then you might need to do some testing. And for each of these things, it turns out that like if you can build an individual agent that's focused on that, then you can test that individual agent independently sort of verify its behavior, make sure it works really, really well. And then you figure out how to sort of delegate across both all. And the third bit is extensive context. And so as you in some tasks, you will need to either process a ton of input. So maybe read a bunch of documentation, the Android documentation, UI documentation for your company, that sort of thing. And as the output, you might need to generate a lot of code, a lot of tests, that sort of thing. Now it turns out that like if you stuff all that stuff into a single agent, I mean, there's all the stuff we know about like model behaviors where, you probably are familiar with Lost in the Middle, where, there was a bunch of experiments that shows that like if the input to the model for every inference step is really large, as it grows larger, the model tends to pay attention to stuff at the beginning and at the end, and essentially just lose context of everything in the middle. And so when you have like a task where like you're processing a lot of context, every time you take a step, you essentially flow the entire thing through a model, and it tends to lose information in the middle. And so you get like degradation there. And then the final piece is, in some cases, your task need might exist in a dynamic environment where every time you take a step, the environment changes. You need to sample it, take another step, observe the state of the task. So, for example, let's say you have like an agent trying to book a flight. Might go to, in this case, let's say a computer use agent. It spins up a browser, goes to flights at google.com. It might click stuff. And every time it makes a click, the web application changes. You need to sample that. Again, things like that just explode context. And fitting all of that into a single agent, especially with this sort of complex task, can lead to like challenging results. And so to recap, if your task is complex and it requires planning, diverse expertise, processing extensive context, lives in a dynamic, probably requires like some dynamic type of environment, then it sort of makes sense to figure out a way to sort of decouple some of these into individual agents that you sort of delegate to. And so I started working on this book like 2 years ago. Our understanding of this has evolved slightly, but this is all still in context. And today, the equivalent of that is the concept of sub-agents. And so if you look at all the stuff with Claude and Anthropic, I think a few months ago, they came up with like a really nice blog post that talks about like the sub-agent behaviors where at any given time, as Claude makes progress, it will spin up sub-agents in the background and delegate stuff to them. Probably write the right instructions on the fly, and sort of get them to iterate on those things independently and sort of come back with just the results. And so, to the original question, should we use a single agent versus a multiple agent? It depends on the task. If it's complex, you definitely get a lot of benefit from a multi-agent or multiple sub-agent sort of architecture.
Clear. Yeah, that makes perfect sense. That's completely aligned with what I have seen as well. In a recent project, we've iterated a ton and we found out that basically contextually, if you give the LLM a task that is too semantically diverse, it loses stuff in the middle, just as you said. It gets sort of confused. So breaking that problem into sub-problems where there's very specific semantic context, then it performs better. But the question I think was a little bit deeper, which is this concept of sort of ensembling in machine learning, where you have many weak learners that
Mm.
ensemble up to one powerful, better learner versus having a really big single model.
Yeah.
Do you have thoughts on where LLMs will fall into that space? Because we can throw up a bunch of like really cheap open source models. They're fast, they're easy to serve, well, easy in quotes, and you merge them together and they produce a complex result. Or should we be getting the latest GPT 5.2 max reasoning?
So when you think about this, are there specific use cases you have in mind? Because I think it matters. Um, it matters to an extent. if we walk back to ensembling, um, I think the power of ensembling is comes from the fact that having multiple models sort of complements the bias of each individual model. And so, and I think in most like ML, traditional ML ensembles, you do see that like you arrive at a better performance because let's say you do an averaging ensemble. It's because this average complements the biases of each of the individual models. Um, and I think when we build systems, like we need to inspect, like if we get a bunch of like let's say 5 or 10 Quen models, if they're all terrible, then like we just get an ensemble of terrible like outcomes, and it'll never be as good as GPT. Um, but maybe if we go a step further and we have some type of like maybe some type of fine tuning process that um, changes the focus or the biases of each of these individual models in some clever way, then ensemble sort of makes sense. In my mind, there's a good example middle ground there is mixture of experts, and so are you familiar with that? And
Yeah.
so I think we've seen a lot of good results where like um, we have this MOE mixture of experts like architecture. And during training, each of these experts they specialize. They specialize in some way. And at runtime, you could a query comes in, you route it through one of the experts. Nothing stops us from decoupling those experts and bolting some type of like just intelligent ensembles on top of them. So now we know these things are doing different things, and we might even go as far as peeling them out or just not just letting the router piece of the model do the routing, but maybe adding some additional logic that it says we're going to ensemble in a specific way if we knew a bit more about the problem. Um, I think the short answer is um, I think that like small models are still very, very interesting, but probably not the way they are, not just base versions of them. It's either we might need to either do things like train them in some, I don't know, maybe on diverse data slices, maybe generate some synthetic data slices that like give them specific focuses, or we go the mixture of expert route, that sort of thing. And that's where we'll see good results. I don't know if that is close to what you were thinking, but that's what my thoughts are right now.
Yeah, I mean, I'm so underqualified to even think about this problem, so
Yeah.
I'll defer to you.
Yeah.
But that
And
makes sense.
another interesting thing is there was this paper recently by Sarah Hooker. I don't know if you know she works at Cohere. She does a lot of good work, and she talks in that paper. I think that the title of the paper is "The Slow Death of Scaling," and essentially, part of her argument is that right now all of the labs are just throwing compute at the problem, um, and maybe that's not a good idea. Have you gotten a chance to think about that? Like, have you been in places where people have talked about that? And I don't know, maybe I think part of her argument is like we probably shouldn't just focus only on scaling or making these models bigger as the way forward to progress, and we should look at other paths. Um, have you gotten a chance to think about that in any way?
I have. I was listening to a couple podcasts with some of the forerunners in the space, and that's definitely an area where it seems like, from what I'm seeing, there seems to be the perception that there will be diminishing returns, and I think
Yeah.
that makes
Yep.
sense. Like,
Yep.
if you just add electricity to a microwave, or that's a bad analogy, but if you just keep pouring
Yeah.
in compute, it can't keep 10xing in the way that we've seen it.
Yep.
So we're going to eventually have a plateau, and
Mhm.
we'll have to have a paradigm shift. I was
Yep.
actually talking about this yesterday. What do you think is the new architecture?
Um.
Like, is it just a bigger transformer with a bunch of multi-agent systems? Because that makes sense. Now it becomes a software and distributed computing problem that's doable,
Yeah.
and just takes time. Or is there
Yeah.
going to be like a world model paradigm shift?
So while thinking about this, like Yeah. I think I to be honest, I don't know. Um,
If you knew, that would be impressive.
yeah, I actually don't know, but um, in these conversations, world models always sort of come up, and so the argument is that like text, the models we have today learn primarily through text, and sometimes text does not capture the mechanics of the physical world really well, physics, all that good stuff, and world models sort of close that gap. I mean, I think text does because like humans have written a lot about like the world and physics, and there's so much you can learn. But maybe there's this little slice, and I didn't know, if world models close that little slice, like how much better are we gonna be overall? Maybe in terms of reasoning and that space, we'll see a lot of impact. And I think one of the critics of like models is or AI today is that um, we haven't had an AI that solved some, I don't know, solve some really complex, difficult problem and maybe cured cancer, that sort of thing. And why is that the case? Like we spent so much money on this thing so far. Why is that the case? And some of the arguments there that like the models, the autoregressive model of today is meant to predict patterns, and maybe solutions to these problems are fundamentally deviations from the pattern. Like, and if you have a model that's always completing tokens, completing text, then it's unlikely it will complete text in a way that is meaningfully different and leads to a completely new solution. Um, and maybe that's the thing that we all have to figure out. And how do we get models that are capable of cognitive leaps? So essentially, being able to deliberately abandon something um, that's common or that's known. And so as we have this conversation, we can switch completely and let's say I don't know talk about I don't know agriculture something like that,
Right.
just by ourselves if we want to. Um, Now LLMs might not be able to do that really really well, and so maybe we figure out a way to bake in some type of reasonable, controlled, divergent thinking into the models. I don't know. It's one thought I have, and or maybe just more more of the world model training might help us get there, or maybe RL might help us get there. Maybe we do RL at a scale that's big enough, and the model starts to figure out that like to get good results, I need to get a new type of emergent behavior, which is divergent thinking, or I don't know, whatever it is scientists do to discover completely new stuff. I'm just spitballing here, but like you never know, Um,
Yeah.
I think with the right experiments, we'll sort of get there at some point. So, yeah.
No, I think you hit the nail on the head. Like, I will never forget one of the most formative, like, one liner that I ever heard was I was doing an internship at Tubi, which is Fox's streaming service. And my manager was like, just put 10 minutes on everyone's calendar. If they say yes, great. If they say no, it's fine. But just try to talk to as many people as possible. So I magically spoke with our head of machine learning at the time, who was like very busy guy, very smart. And he brought up the point that data driven decisions can only lead to incremental progress, usually. And that's exactly what you're saying. Basically, if you're taking the corpus of text and predicting the next token, it's a fundamentally data driven decision that is autoregressive and backwards looking. If you're trying to do innovative things, you need to break up the solution space, and iterative search models like a stochastic gradient descent, that won't have the same effect. You want to basically throw a dart on the dartboard and try it.
Yeah.
So that's what it seems like we've been overlaying problem solving heuristics and frameworks, like, for instance, Claude Code's plan model. It'll explore before it starts generating the solution to the code, and it'll generate a markdown file with a plan. So we've overlaid like logic theory, but you bring up a fascinating point. Like, will LLMs have this built in?
Yeah.
And I
Yeah.
have no freaking idea.
Yeah. Yeah. So it's either we do this, either the model has this like innately, which might be more effective, or we have all this like agentic scaffold
Yeah.
built on top, that gets the model to to do it, and maybe that's enough. Yeah,
Which do you think it'll be?
I think we so the model piece is a lot more complicated, a lot more difficult. I think in terms of just effort. Um, and so I think all the cool stuff we're seeing around like agentic harness and frameworks, things like what Autogen and the Cloud Code harness is doing, is mostly an effort to get the model to explore all these behaviors that we are interested in and we want to extract from it. That's not natural to the model itself. Um, so I think we will we will take the typical engineering path. We'll start with really large models that have like really broad world reasoning, um, and then we'll put build scaffolds around them to extract behaviors we want from the model. And then as the model gets better, we'll shrink the scaffold. I mean, we're already seeing that today. Every time you listen to the cloud code folks talk, essentially what they talk about deleting half of the code harness every few months. And so um, as the model says get as the model itself gets better stuff, we'll reduce the importance of the harness. But it's a cyclic thing because the model getting better means that like this harness did its job. We figured out all the blind spots of the model. We generated like new training data, or we use that knowledge to figure out how to make the model better. Now the model's better. We trust it a bit more and we reduce the complexity of the scaffold. And so in the last chapter of my book, I have this little graph where um, there are two lines. And one is the complexity of agentic harness scaffolds. And I think that stuff is just going to go down going forward. And the capabilities of the model will probably stay the same or trend upwards. But the raw performance of the model itself will just trend upwards. And so I see it as more of like a moving target where for now we're getting all that value from the harness. Um, and as we better understand what are good behaviors or the right ways for a model to behave, we can figure out what are the blind spots of current models. Then we'll train the models, we'll make them better. And then we'll reduce the complexity of the harness so that the harness doesn't get in the way of the model. And we'll sort of see that sort of iterative process. Yeah.
Yeah, I mean that makes a ton of sense. It's a Have there been paradigms like this in history before? Like where you have a highly deterministic system that then is used to train a self-organizing system and it like optimizes into like this seems new. I'm not well versed, but
I think I think the main difference is that this thing we're optimizing is quite intelligent. So there's a
right.
ton of intelligence there. I think we just have never had anything at that level of intelligence. And there is it feels like new territory. Yeah. And unfortunately this is just one of those spaces where it's more engineering than theory or science. Um and there's um my colleague at Eric Ju, who worked on who also we both worked on Autogen. He wrote an article recently that just talked about how um, it's now the era of the builder and the experimenter, because like the things we're learning the most, it's just coming from tons of experimentation as opposed to say a mathematician saying, hey, here's the right way to structure like intelligence or structure, I don't know, divergent thinking, that sort of thing models. So yeah, I'm not sure I have a good analogy for something in history, but I probably don't because we've never had like a chance to optimize something at this level of intelligence, a base model at that level of intelligence.
Yeah. What a time. Well, all right. I think we've covered a lot. Let me summarize. Per usual, very random discussion, but I think we covered some really fascinating topics. Some things that stood out to me. First, when you're early in your career, try to optimize for learning. and later in your career, you should think more long term and be more strategic with your planning.
Hmm.
Throughout the entire career of at least Victor, it seems like focusing on solving problems has been a hallmark, and that can guide you towards working on useful things. So just try to solve something that's useful. Um, for Autogen, it was born out of a few tenets. The first was being async, actor first, and having a high level chat API. And then the second component is semantic kernel has focused more on production readiness, and it has merged into this Microsoft agent framework, which is sort of the future of what Microsoft is betting on.
Hmm.
And then after that, we kind of went into a bunch of things, but I suggest simply just buying the book, Designing Multi-Agent Systems, and reading what Victor has to say about that for a recap. There's too much to summarize. So, Victor, if people want to learn more about you or your book, where should they go?
So the book is on multiagentbook.com. Pretty easy. You should be able to find that. If you'd like a discount code or something, I think there's one right now. And to reach out to me, it's just LinkedIn. And so if you search for Victor Dibia on LinkedIn, you should find me. I can try to write quite a bit. I do have a newsletter, so newsletter.victordibia.com is also a great way to keep up with what I think, my thoughts on just emerging topics in the space. Yeah.
Amazing. All right. Well, until next time, it's been Michael Burke, and have a good day, everyone.
Alrighty. Thank